Welcome and hello. This is a video lesson in MODSIM, and what we're going to be talking about in this lesson is scenarios analysis option, the statistics and exceedance probability. So these are a few different ways to view results in MODSIM. All right, what I have on the screen is a blank MODSIM. I don't have any networks loaded, but that's what I'm going to do now. I actually already have 5 separate networks loaded and ready to go. So I'm going to go up to File, Open. Here are the networks I have prepared. I'm going to just open one network for starters, network 1 we'll call it, and then here it is. All the other 5 networks are identical to this network with the exception of increased inflow. So we'll see how that change affects our results moving forward. There are a few things to mention here. This link just downstream of the reservoir has a max capacity of 50,000 acre-feet per month. Although it is allowed to spill and go over, that would be a penalty. Also, this downstream demand node D1 has a demand of 20,000 acre-feet per month. And we'll also see that pop up when we view some of our results. So just making mention of that now. If you're curious about how I built this and some more details of the model itself, check out exercise 11, the MODSIM exercise 11 called Results, Statistics, and Scenarios Analysis. But here we're just going to talk about the scenarios analysis, the stats and exceedance probability. Scenarios analysis in MODSIM allows the results from several networks representing alternative scenarios to be compared simultaneously. We're going to see that in action, but first I'm going to just view data from one single network so we can kind of compare and understand the additional benefit of using the scenarios analysis option. All right, so with that unselected, I'm going to right click and then click on the graph. I've already ran the model, so we do have results here. Here is the plot. This is the flow that is leaving that node, our non-storage node here, NS1, and then I can expand and local inflow. So that is all my data. This happens to be a 100-year simulation with a 1-month time step. Now in the top right here, I can minimize, mobilize, or close this particular network. If I click on what I call mobilize, the network window is no longer maximized within this frame. I can move it around, I can resize it, and so on. And then I can also select it and organize it using the options here in the window menu. I'm going to go ahead and open up the other networks now. So let's just go up to File, Open, or I can also open by clicking on this Open button right here. All right, let's select networks 2 through 5 and click Open. All right, so those are opening up. Now I can organize them by selecting on the network I want. Like I said, they all look identical except for the inflow. And then I can also like mobilize them and make them smaller, or at least so I can see multiple at the same time. Also, and if I go to Windows, I can click on Cascade, and that sort of organizes them like that. There's a few other options like horizontal, okay, vertical. I think if you had like just two, it'd be more obvious the difference between horizontal and vertical. Let's go ahead and toggle on that scenarios analysis feature now. Okay, so what it says in this dialog box is basically with this scenarios analysis feature enabled, when you click to view the graph of model results, it will open the results for all the networks opened in the MODSIM program, which is convenient. So for instance, let's just compare the difference between the inflows. So let's just stick with network 1 here. I'm going to go right click and now graph. This is for NS1. And now it opens all 5 of the NS1 elements for all of the networks 1 through 5. Let me go ahead and close that. Let's take a look at the reservoir data now. So right click, graph, and as before, it's going to open up the reservoir data for all 5 networks. There's flow data followed by storage data. Now this legend is kind of in the way. It's got 10 different records and we don't need all that. So let me just toggle that off real quick. I'm going to go to options and then chart options. And then under legend, there's the chart tab and then the legend tab. Go ahead and just uncheck that visible checkbox and close. So I have a little bit more space on my screen now. If you want to zoom in and see more detail, which you probably want to if it's 100 years of data, you can just left click and then make sure to drag kind of in the southeast direction. You continue zooming in that way. And then if you want to zoom out, you can just see left click, but drag the other way, kind of northwest, and boom, you drag it, you zoom out to the full extent of the plot. I'm going to set the left axis to flow, and it looks like it already is. And then I'm going to expand and only show the flows for the storage release. I don't need to see the upstream inflow or the downstream flow, which I think is the storage release. So let me go ahead and do that for all 5 of my networks. Okay, so I did that. I'm only seeing 5 series of data here representing the reservoir release for the 5 different networks. And as you can tell, there's a distinct line at 20,000 acre feet per month and 50,000 acre feet per month. Because like I mentioned, if there's plenty of water, the reservoir doesn't want to release less than 20,000 acre feet per month. Or if there's too much water, it's trying to still not release more than 50,000 acre feet per month. However, we still have some months of shortage down here and some months of spill up above 50,000. I want to talk about the statistics. So at any time, you can right click on one of these series of data and then click on statistics, and it gives you that statistical information. So what we're looking at here is the release from network one. It has a maximum value of 50,000 acre feet per month, a minimum of 3,110 acre feet per month, and then you can read the average, the sum, the count, standard deviation, and variance values. So these are just text values. I don't think when you click on them, left or right click, it does anything. But you can check out another series of data, and this is for all 100 years and all 1,200 records here. That's what the count 1,200 means. So here we have no shortage and also no spill, since we have a maximum and minimum within those ranges. All right, so this is a quick way to look at statistics for that particular series. Also in this dialog box is flow duration curves is what it's labeled. I call this the exceedance probability chart because it's pretty much the same thing. So let's go ahead and open that up for, say, just network one. I'm going to right click on my storage release flow duration curves. And now what we're seeing here is a percentage of the time of the reservoir release from network one in the simulation. And you can tell for the vast majority of time that the reservoir is releasing 20,000 acre feet. In fact, only about 12% of the time is it releasing more, up to about 50,000 acre feet, and then about 4% of the time it's releasing less. So you can just look at a plot like this and very easily get an idea of what the reservoir releases are over 1,200 different records and 100 years of data. So that's very helpful. And what's more helpful is comparing this data with that from another network. So in this example, we have 5 networks. We're varying the inflow data, and that should be reflected in the releases based on the logic and how the model was set up. So let's go ahead and add another series of data to this exceedance plot. It's called duration curve. So up here at the top, I should probably mention we were looking at plot before, and then there's a data tab. But when we go right click and flow duration curve, it automatically brings up this flow duration curve tab and selects it for you. Okay, so let's add network 2 now. I'm going to go right click on the network 2 storage release, flow duration curve, and boom, that orange line is our network 2 data. It just added it inside the same plot as our network 1, and it shows that we have no shortage because this 20,000 acre foot per month value goes all the way down to the 100%. And it looks like there's more spill. Actually, this isn't spill. Above 50,000 acre foot would be spill, but it looks like 100% of the time, this network 2 releases between 20,000 acre foot per month and 50,000 acre foot per month for about the top 8% of the time or so. Okay, I'm going to add the same exceedance plots for networks 3, 4, and 5. So here's network 3, right click, flow duration curve. Network 4, right click, flow duration curve. And network 5, right click on my storage release and flow duration curve. So you can see with each different network, as we have more inflow, the reservoir has to release more and more water. For this 5th network here with the most inflow, that's this navy blue line here, we're never releasing 20,000 acre feet per month, maybe at the very bottom here, but we are releasing somewhere between 20 and 50,000 acre feet per month for about 60% of the months. And then for about, we'll say maybe 25, 28% of the time, we're releasing 50,000 acre feet per month. And then I'd say the top 3 or 4% of the time, we're actually spilling above the 50,000 acre feet per month. So it's incurring a penalty for time. Now, nothing that we've seen in this lesson, whether it's the exceedance plots in this screen or the statistics right here, could we not do by ourselves. We can go up to the data, tab right here, click on the plus button, click on any of these data tables. So reservoir one, for instance, then I could scroll over. I could get my reservoir release right here. It's called storage release. I could export that data, plop it into Excel, and basically get the same statistics and exceedance probabilities by building it myself. But I'm just making this lesson to demonstrate how this is all built into MODSIM, so someone could very easily glean these results and not have to mess around with exporting data into a separate program. All right, well, that was it for this lesson. We talked about the scenarios analysis tool. It allows us to compare multiple scenarios, multiple networks results at the same time easily, as well as the statistics and the exceedance probability, both individually and grouped up with multiple networks.